Welcome students. This is the topic on polynomials. Now this topic that I will be doing from this time forth is targeted for CBSE Class 10 students wherever they are in this syllabus, and it doesn't matter which geographical continent that you are actually live in or you study in. It doesn't matter. This will cater to your needs if you are studying in class 10 or you are in class 9 and moving on to pursue class 10. So it can also act as a preparatory course for you all. The entire class for this particular season would on this particular topics and topics coming forth will be handled in the language of English. So all the terminologies, the working, the solutions and the problem discussions, everything will be done in the language of English. So having mentioned this class will be the appropriate class for you if you are aiming to score top grades in your class 10 examination. Not only that, it will also prepare you further in whatever area that you wish to aspire. Having given these few words and got these things out of the way, let us get started. So foremost, what is a polynomial? This is the vital question that you will have to be asked, and the solution is too simple. If you have your textbook, you can follow my course along with the textbook. That would also be supplementary work for y'all. So the appropriate definition is as follows. A polynomial is an expression that which is composed of variables, constants, and exponents that are combined to a monomial or a binomial or a trinomial or a quadrinomial or a pentanomial, and so on. Now, of course, you might be wondering what monomial, binomial, trinomial, quadrinomial, pentanomial, what are these? These sound more like a jargon. Don't worry, I will explain to you all of this. Now, this is the crude definition of a polynomial. But if you're looking for the actual form of a polynomial represented mathematically, then this would be the answer. An expression of the form. Let me give you the form. P of x is equal to, you can start it like this, a0 plus a1x plus a2x squared plus a3x to the power of 3 plus etc. And the last but one term would be plus an minus 1 x raised to the power of n minus 1 plus an x to the power of n. So this would be the mathematical representation of a polynomial. It can also be written starting from this side, anx power n. It can also be in this fashion, anx to the power of n plus an minus 1 x to the power of n minus 1 plus an minus 2 x to the power of n minus 2 plus etc. plus a0. So either this or this. Now what are these a0, a1, a2, where a0, a1, a2, etc. an are called as constants. Now what do you mean by constants? They do not change. They do not change in the middle of an operation. Now when I say operation, say for example, you are multiplying two expressions of this fashion, say 9x squared negative 3x, and then you're multiplying it with 4x squared positive 2. When you multiply, there is an operation that has been performed, that is multiplication. The moment you act on when this term 9x squared is multiplying 4x squared, when that act is committed, the value of the 9 will stay as it is during the course of the operation. After the operation is completed, a result is produced, right? That is a different part of the operation. So while the operation is being moving up to be performed, 9 will remain 9. So the constant means a quantity which will not be altered during the course of an operation. Now you might be saying, what, 9x squared times 4x squared, we are getting 36x squared with another x squared. Is it 36 not a different quantity? It is a different quantity. You are perfectly correct, because this quantity 36 is actually with x to the power of 4, right? So it is a new constant which is holding on to a new term. So have that in mind. Okay, having mentioned that, I need to talk to you about x1, x2, x3, right? Now, in general, the x that is being seen here, so when I say x1, it means x to the power of 1, x to the power of 2, x to the power of 3, and so on and so forth, x to the power of n. That x is what is called as variable. Now, when you say variable is something that the expression holds and it is subjected to change. So remember, this quantity is subjected to change. Okay, so having mentioned that, having described you the concept, or I would say what a polynomial is, and looking into a polynomial from mathematical perspective, discussing about the constant and the variables, it's time to study about the concept of varieties of polynomials. So I started off saying that monomial, binomial, trinomial. So you need to know what is the monomial, what is the binomial, what is the trinomial. So those terms are imperative to be understood. Okay, so moving on. So the noteworthy point before we could move on is this. This is the mathematical way of representing the polynomial. Have that in mind. So now we will start off with types of polynomial. Types of polynomial. Now the first prominent type is called as mononomial. Let me define it, right? It is an expression which contains just one term, no more than that. So if someone is asking you to give an expression of monomial, what you need to do, or an example with monomial, you can clearly say that 5x is a monomial, 71 is a monomial. Now, it is not necessary that the variable that you see should always be x. You can also give 7a to the power of 4. This is also a monomial. This is also a monomial, negative 31 x squared y. So the term occurs just like that, a single term. So that is important for you to understand what is a monomial. Now, next is binomial. So it is an expression which has or contains two terms. Exactly, maybe you can use the word exactly two terms. Now the terms can be of this form: 7x to the power of 2 negative 3x. This is one example. 5xy plus 3, right? This is also an example. Make sure that the expression that you're giving has got two terms. That is the basic our understanding that is needed here. Now the next important is trinomial. Trinomial what? Trinomial is nothing but it is an expression which contains exactly 3 terms, right? And some examples of trinomial can be negative 3x to the power of 3, positive 2x squared, negative 7. This is a trinomial. Now I'm giving you all expressions, right? Have that in mind. The key word is expressions. You have to make sure that you're able to get this. This is an expression. There's a lot of difference between expression and an equation. Have that in mind. So when you say equation, if I were to write it like this, say 3x to the power of 3 positive 2x squared negative 4x, if I were to write it like this and equate it to 0, then this would become an equation because I'm equating it to 0. If there is no equation or no equating with 0, then this is called an expression. So now we can go forth and give another example, say 4x to the power of 2 positive 19x negative 7, so or 71 or positive 71. This is an example for trinomial. So having given you these illustrations, of course you can go on by increasing the terms. It is now becomes imperative that you understand the term degree. This is a very important concept in polynomials. So what is the degree? Let me state that here. The degree of a polynomial is defined as the highest exponent of the term. So when I say term, it means the individual term present within the polynomial, right? Present within the polynomial. So if someone is asking you, what is the degree of this polynomial? In general, remember, whether it's a monomial or trinomial or binomial, no matter what nominal element or expression that we're dealing with, they all will have a degree. So in this case, we are dealing with trinomial. So in trinomial, what is the degree of this trinomial? If someone is asking you what's the degree, you will have to go to that term which has the highest exponent. Now anything that you place here is called an exponent. The exponent is 2 here, exponent is 1 here. Actually this has an exponent 0. So the degree of this trinomial is 2. Okay? And does a constant present in a polynomial, does it have a degree? Of course it has a degree. Now this is constant, right? Now what's the degree of this constant? Is 0. But we don't express it. We will express it if it comes individually as a question. Say for example, let me give it over here. Somebody is giving you p of x is equal to 7. Now this is a polynomial. Why is it a polynomial? Because it is categorized as a monomial. But this can be written as 7x to the power of 0. And as I mentioned to you, if someone were to ask you what's the degree of this p of x, the degree is 0. Right? So let us recap what we have studied. So we started off with the definition of polynomial. A polynomial is an expression which is composed of variables, constants and exponents that are combined to form a monomial or a binomial or a trinomial and so on and so forth. Right? That's the crude way of explaining the polynomial. Now mathematically, what is the form of a polynomial? A polynomial can be represented either in this fashion or in this fashion. In most of the cases, we will stick to this fashion. A suffix n, x to the power of n, positive a suffix n minus 1, x to the power of n minus 1, etc. Okay, up until a naught. Now what are these a naught, a1, a2, etc. a suffix n? They are called as constants. Now what is a constant? They don't change. And x, what is it called? X is called a variable. They are subjected to change. Now as you progress in this course, you will understand what it means to be subjected to change. I'll explain to you further down. And then we embarked on learning about the types of polynomials. So we got monomial, we got binomial, trinomial. These are all standard polynomials. Monomial is a polynomial where it has only one expression. Examples are given here. Binomial has got 2, trinomial has got 3, and so on and so forth. And then we came to a very all-important term, what is called as degree. Now, since we have come to the point of degree, now let me give you some examples connecting degree. Okay, find the degree of p of x. Now usually polynomial is represented as p of x, but it can also be represented as f of x. It doesn't matter, p of x or f of x. Now we are asked to find the degree of p of x is equal to, say, 3x minus 2. Now what is this called? Now this is called as a linear polynomial. Linear polynomial. Linear means the degree of x will be 1. So in this case you can see the degree is 1, but they don't specify it here. So the degree is equal to 1. Now this is the first illustration. Let me go up to the second illustration. So p of x is equal to, say, 6x squared negative 3x positive 2. So they're asking us what's the degree. Now this polynomial is called as a quadratic polynomial. This is all important polynomial. Of course, 1 and 2 are very important. And whenever they say quadratic, the degree is 2. Remember that. And example 3, cubic polynomial. Say p of x is equal to 3x to the power of 3 positive 2x squared negative 13x positive 7. You can clearly see that this is actually a form that I specified about polynomials. We got 3, 2, 13, 7. They are all constants. So suppose someone is asking you, what are the constants in this polynomial? Then you should be in a position to state that 3 is a constant, 2 is a constant, negative 13 is a constant, 7 is a constant. And what is the variable here? There is only one variable. We will be dealing only with polynomials of this type or of this type or of this type in this course. So you can simply see the variable that is present here and mention it. Remember, it is not necessary that the variable should be always an x. Suppose they are giving a polynomial like this. They can also give a polynomial like this. P of t is equal to t to the power of 4 negative 3 times t cubed positive t minus 5. And they are asking us what is the variable here. Suppose this is the question. Constants, variables, and what is the degree? The degree is the highest exponent that you see on the variable. In this case, the highest exponent is 4. And the variable that you see here is t. The constants that you see here is the number that is holding on. We have a new term for that. We call it as coefficient. C-O-E-F-F-I-C-I-E-N-T. We call it as coefficient. As you progress in this course, you might be encountering this term. They will ask you, what is the coefficient of t raised to the power of 4? What is it? What is the number that is present with the t raised to the power of 4? That's 1. And suppose they are asking you, what is the coefficient of t raised to the power of 3? What is it? It's negative 3. Right? So that is a side note for your understanding. So these are some of the illustrations for polynomial. And what if I have a polynomial like this? Say p of alpha is equal to alpha to the power of say 5 negative 3 times alpha to the power of 4 positive 7. Is this a polynomial? Yes, this is a polynomial in alpha. Then what is the degree? The degree is 5. I can clearly state it. The degree is equal to 5 and the variable that we are seeing here is alpha. Now degree 4 polynomial is called as quartic polynomial. Q-U-A-R-T-I-C. Quartic polynomial. Degree 5 polynomial are called as quintic polynomial. Right? Quintic, quartic. Now as you progress, suppose you are getting into the field of engineering, you will see polynomials that are in this nature. Quartic polynomials and quintic polynomials. They will definitely be a part of your course. depending on what area of engineering that you are studying. So that is a good introduction for our study on polynomials. Now the most important thing now is we need to head on further down in seeing other illustrated examples. Now before we head on to the next topic, I want to give you a problem. The problem is select the choices which aren't a polynomial. Now the key word is which aren't a polynomial, right? So I'm giving you the choice. Choice 1, 3x negative 4. Choice B, 7x to the power of 4 negative 4x positive 7. Choice C is 2u cubed positive 5. Choice D, root of x negative 7. Choice E, 1 over x squared positive 2x negative 3. Choice F, 1 over e raised to the power of x positive 4. G, e raised to the power of pi times x squared negative 5. I can give you probably 10 seconds. Okay, I hope you all have got the right solutions. Now the question wants us, select the choices which aren't a polynomial. Is this a polynomial? Of course this is a polynomial because this is in the standard form. The only thing is that this is called a linear polynomial. And what is this? Is this a polynomial? Yes. This is linear. This is cubic polynomial. And what is this? This is also a cubic polynomial. And the variable is u. So this is 2u cubed positive 5. Is this a polynomial? What is this? The square root of x. What is the square root of x? It can be rewritten as x raised to the power of 1 over 2. This is the exponent. The exponent is actually not a whole number. Right? When I say whole number, it is not a 2 or a 3 or a 4 or a 0 or 1. So that is the meaning. This quantity which we see here, it should be a whole number. It should be a positive number. Right? When we say whole number, the set of all whole numbers starts from 0, 1, 2 and goes up. Right? So it should be part of the set. But that does not mean that it can take infinity. The set of whole numbers goes up all the way to infinity. But we don't deal with polynomials in that fashion. We take a quantity as an exponent such that it is manageable, right? So I'm just giving you as a large set such that I will place in the restrictions. Instead of saying infinity, I will say n. That's all. 0 to n, right? And this clearly defaults. The square root of x is not a polynomial, so that is just straightforward. What is this? This is x 1 over x squared positive 2x negative 3. If you were to write it, this is going to be x squared positive 2x negative 3 raised to the power of negative 1. And this is not a polynomial. We have not studied a quantity which is raised to the power of negative 1. So this is not a polynomial. Also, what is this? This is 1 over e raised to the power of x negative 4. E stands for exponential function. This is altogether a different family of functions. So this is not a polynomial. So this is not a polynomial. This is not a polynomial. Same as this. This is e raised to the power of pi times x squared negative 5. This is also not a polynomial. So all these choices D, E, F and G are the right choices for this particular question. And having dealt with that, let us move on to the next topic. Now in this topic we will be understanding what is called as zeros, right? Zeros of a polynomial. Now zeros are also called as roots of a polynomial. Now in simple terms, whenever they are talking about zeros, what are they looking for? They are actually looking for x intersection. Simple as that. That's the simplest way to understand this term, x intersection. You need to get x intersection. Now let me give you this illustration. Say for example, you have y is equal to say 2x positive 3. This is what they have got. Now this is a polynomial. Now instead of giving us as p of x is equal to 2x positive 3, they have given us as y. Now what is y? Can you tell me what is y and what is x? I already mentioned to you x is a variable, right? X is a variable, I have mentioned to you. But what is y? Y is also a variable, right? But there is a difference between these two variables. X is called independent variable. Y is called as dependent, right? Have this in mind. X is independent variable in this case. Y is dependent variable. So what is the meaning of dependent variable and independent variable? Simple. Y depends on x. In other words, suppose you are actually taking values, right? You are free to take values only for x. You can take values only for x. You cannot take values for y, right? You cannot take values for y. Suppose I'm taking values as say 0, 1, 2, 3. I can take values for x like this. Negative 1, negative 2. I can take values for x like this. For every value that x is taking, y will take a designated value. In other words, y has got no choice at all. X has choices because of the very fact independent. Just like you are studying. Why are you studying? You are studying to be independent in life, right? That's the understanding that you need to know. You're not studying for your parents are forcing you to study, or your school is forcing you, your teachers are forcing you to study. No, no one is forcing you to study. You are studying to be independent in life. Now, what is the meaning of independent when it comes to life? Say, for example, you're thirsty, right? You're thirsty. Now, suppose you are in your family. Imagine you are in your family. It can be anywhere. It can be with your relatives' house or in your friend's house, friends and family, right? You're thirsty and there is a cooler here. This is the cooler, right? The refrigerator. And there are a lot of good beverages, say drinks are there. And there is a fruit juice. And there is a bottle of water. The refrigerator is stacked with these beverages. Now, you are free to go and pick out the water that you want or the fruit juice that you want. Now, you don't want to get up from your chair or seat like that. You're asking someone, say you're asking X to get you this water. X will help you. So you are here. X will help you. X will help you once. Again, you're asking X to come on, fetch me water. It will help you twice. But the third time, X will say, why are you troubling me? So that is the simple way of understanding. In life also, there's a lot of difference between being independent in life and being dependent in life. When you become independent in life, you don't have to depend on any entities for your existence, for your survival, or for you to achieve what you want. You can just get up from your chair and go get it. So that's the crude way. So education gives you independence and also choices in life. So that is the power of the x variable here. But y variable has got no choice. So in this case, if I were to take x is equal to 0, y becomes equal to 3. X is equal to 1, y is 5, this is 4, 7, 3 to the 6 and 9. So these are the values that y is taking. Minus 1, this will be 1, and minus 2, this will be minus 1. So these are the values that y takes. Okay, now so much so. Now coming to the point, we need to know the x intersection. Now how are we going to get the graph for this? Now remember, we have taken y is equal to 2x plus 3. And what do you call this polynomial? This polynomial is called as a linear polynomial. What do you mean by linear? The degree of x is equal to 1. So let me draw the graph. So this is going to be a straight line graph. Whenever you're drawing a graph, draw two lines. Draw the x-axis and y-axis. When you are drawing the x-axis, make sure to place the arrow and write x there. You don't have to place an arrow here, but you should place an arrow mark here. And similarly, you need to place the arrow mark here, x and y. You don't have to place the arrow on this side. You don't have to place an arrow on the down, because this shows the line is extending. But this is imperative. X-axis, y-axis. Now, then you mark the points. I'm going to take it as 0, 1, 2, 3, 4, 5, and so on and so forth. This side becomes negative side. So negative 1, negative 2, negative 3. Here you can mark it up as 1, 2, 3, 4, 5. So coming to the point of y, I need to plot 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. So you might be asking me why the space is little, because I don't have any space here. So that's the reason I'm spacing it out. So this is negative 1 and negative 2. So you can plot negative 1 here and negative 2 there. Now just observe this. When x is 0, y takes the value 3. 1, 2, 3. When x is 1, y takes the value 5. When x is 2, y takes the value 7. And x is 3, y takes the value 9. Right? And when x is negative 1, y takes the value 1. When x is negative 1, y takes the value 1. So that's over here. When x is negative 2, y takes the value negative 1. So negative 1 is over here. Right? Now let me just draw the lines. Okay, so there is an intersection. It's a straight line, so there is an intersection. So this is the intersection. Now watch here. When we talk about zeros, we are looking at the point where this line is intersecting the x-axis. That is what we need. If you are drawing this on the graph sheet, you will be able to find it out. But how are you going to find it out in this case? It's very simple. What you need to do is, to find the 0, just take 2x positive 3 and equate it to 0. Right? You push this 3 on the other side, you get negative 3. So you got 2x is equal to negative 3. Now you divide by 2 both sides. Divide by 2, I divide by 2. 2 and 2 gets cancelled. I get x is equal to negative 3 over 2, which is negative 1.5. So the meaning is, at this particular point, x is equal to negative 1.5. So if they're asking you to write the solution set, you have to say negative 1.5 is the solution set. Right? So that is the intersecting. So if they are asking you, what is the 0 of p of x? X is equal to negative 1.5, or you can write x is equal to negative 3 over 2. That is the 0. So just to give you a recap, when we talk about 0, we are talking about the graph's intersection with the x-axis. Now this is actually called a function. Why is it called a function? For every value that x is taking, there is a value produced by y. X is called the independent variable. Why? Because x is free to take any values, and y is called the dependent variable. Right? So that is another important point. Now they might even ask you to give you the ordered pair. Now if they are asking you to ordered pair, you have to give two values. That means you have to give the value for x and the value for y. So when x is equal to negative 3 over 2, what is the value for y? So y is nowhere. I don't see any y at all. I only see the value of x. So y is equal to 0. So the ordered pair in this case is going to be negative 3 over 2 comma 0. So that is the solution. Right? So the function actually becomes 0. Right? The function actually becomes 0. Now this is a very important concept. You will have to understand this. This is a very important concept in many applications. In many applications. So probably as we move on, I will give you related examples for you to understand. But for now, I think the concept is well explained. Now we need to move on to understand the zeros of a quadratic polynomial. When we talk about quadratic, we're talking about polynomial involving degree 2. So I will show you now how to obtain the zeros of a quadratic polynomial. Jesus. Students, we will now learn how to graph a quadratic equation, or it's better for me to state it as quadratic function. So let me assume that we have a quadratic function of this fashion. Say y is equal to x squared negative 3x negative 4. This is what is given as an illustration in your textbook. So we will learn how to draw this graph. So first, what you need to do is you need to create a tabular box like this, or tabular form like this, and then you will have to space them out like this, and then you have to take x on the top column, y on the bottom column. You have to start from the center, taking 0 to be the central value, and then moving towards the right with 1, 2, 3, 4 and 5. Moving towards the left is always negative, negative 1, negative 2, negative 3, negative 4 and negative 5. Now for every value that x takes, you have to take the value or find the value that y takes and place it in this box below. When x is equal to 0, you get y is negative 4. When x is equal to 1, you get y to be negative 6. When x is equal to 2, this is also negative 6. When x is equal to 3, this is also negative 4. When x is equal to 4, you get 0. When x is equal to 5, you get 6. Now, I will show you how to perform one substitution. Say x is equal to 4. Now, take this given function, y is equal to, x is equal to 4, substitute 4, raise it to the power of 2, substitute 4, and then followed by negative 4. 4 squared is 16, 3 times 4 is 12, and negative 4. Negative 4 added with negative 12 would give you negative 16, added with 16 would give you 0. You don't have to show this to the examiner, but it's always better that you divide your page into fair and rough. This side is fair, this side is rough. It is always better you perform your working on the right hand side, on the rough side. Now, this is advantageous in two ways. One is that you're showing the examiner that you have applied. Even you are not able to get the correct solution. Many times students think that they have to get the correct solutions in a math examination. No, it is not necessary. But you will have to show to the examiner that you have diligently tried. That is important. You made an effort diligently. And how are you going to show that? Everything has to have a proof, right? If you are not providing an evidence, the examiner is not going to believe. And what is the evidence? How are you going to prove or show the evidence? Through the rough column, right? There are questions which would be really challenging. They are putting that question in place just to test the student, right? Examination is the way in which people test to find out what you have done over the period of 1 year. And that is the way, or that is the only way that is available. Without examination, there is no way to test the candidate's ability or candidate's knowledge on the subject. So, if you are going to be dividing the page into into fair and rough, and performing these calculations on the rough side, it gives the examiner a better understanding of the student, because the people who are correcting the paper, they will be anywhere in the world. We don't know where are they from. But this will convey to them that you are a diligent student. Everybody wants students who are hardworking, and it is right. It is imperative that you also stand up to your expected expectations. Okay, having mentioned this, let me move on to complete the table. Negative 1 is 0 and negative 2 is 6, and so on and so forth. You can fill it up. Now, the most important thing here is to draw the graph. So I'm going to start it off with the y-axis, y, and then with x-axis. Okay. make sure that you name the axis, x-axis, y-axis. This is 0, 0. Now you can either represent the ordered pairs. This is the way. This is called as the ordered pair. Ordered pair. Now what it means by ordered pair? Take the first element from x and this next element from y. 0, -4. Then 1, -6, and so on and so forth. This will help you not to make any mistakes. And 2, -6, and 3, -4, and 4, 0, and 5, 6. Right? So you can have a chart 0, -4. This is 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6. And this is 1, 2, 3, 4, 5, 6. -1, -2, 3, -4, -5, -6. Okay? So 0 is here, -4. 1, 2, 3, 4. -4 is present over here. So what you got to do? Plot it like that. So you've already placed -4 there. And next, so this is finished. 1, -6. 1 is here, -6 is over here. Plot it. This is finished. 2, -6. 2, -6. So that means there is 2 particular points. Okay, that's fine. That's finished. 3, -4. This 3 is here, -4 is over here. Right? Plot it. That's finished. 4, 0. 4 is here, 0 is here. Plot it. That's finished. 5, 6. 5, 6. That's going to be up. You see the graph is moving up. So 5, 6 is going to be 1, 2, 3, 4, 5, 6. 5, 6 is going to be over here. So coming to the other side, -1, 0, -1, 0. So that is going to be over here. And then 2, 6, 2, 6, 2, 6. That's going to be over here. Right? Okay, fine. Now connect all these points. Connect all these points. Right? Connect all these points. Now there is a intersection over here, intersection over here. What is this intersection here? When x is -1, there is a 0 there, and x is 1, 2, 3, 4. When x is 4, there is a 0 there. So these are the zeros, right? Now what do you call this? U. It's a U-shaped graph. U-shaped graph. And what do you call this graph? This graph is called as a parabola. P-A-R-A-B-O-L-A. Parabola. Right? Have this name in mind. Parabola. This is a U-shaped graph. And is there anything else? The zeros. What are the zeros? Starting with a negative value. -1, 0 and 4, 0. These are the two zeros that are seen here. -1, 0 and 4, 0. Is there anything else? No, we don't need to specify anything else. So the most important thing is to take out the points for x and find out the points for y and order the elements in this fashion, make the plot, connect the points, and then find out where the x-intercepts are, mention it as the zeros. Of course, this is a U-shaped parabola. Now for your syllabus, you will study two different types of parabolas. One is a U-shaped parabola, the other is the inverted U-shaped parabola. Okay, so that shape would be like this. This is just a side note. Okay, so this question is completed. So what have we studied in this question? We have learned how to draw the graph for this particular function. We call them as function, and we have also found the zeros. Zeros are nothing but those points where the graph cuts the x-axis. So have that in mind. And let us move on. Okay, now let me ask you this question. Find the zeros. Find how many zeros does this graph as, right? So I have a graph like this. So it goes like this, hits here. This is one graph. There is another graph I'm giving. In this case, it is hitting here, just one touch, right? So this point is say A, and this point is say A dash. So how many zeros do you think? Just one. Number of zeros here, it's only one. Number of zeros here, it's only one. There's only one point of contact. That point of contact is also considered as an intersection, right? So though the touch is treated as a touch, yet it is considered as an intersection. So have that in mind. Okay, next illustration. So this is A, this is B. Let me give you C. Can you find out the number of intersections this graph has? And then D, can you find out the number of intersection this graph has? Can you tell me? In this case, there is no point of contact with the x-axis, okay? In the other case, you can simply state no zeros. But there is a mathematical way to tell these zeros. So in this case, the graph as, now as I mentioned to you, the zeros are also called as roots, right? So you can state here as one real root. This is also an alternative way. This is a side note for you. This has also got one real root. This has got no zeros. So you can state it there, no real root, right? As you move up higher in your academic career, in your academic life, you will be facing this terminology, real roots and no real roots. So in this case, no real root. So we have a specific name for that, but anyway, I will reserve it when we come to that particular topic. In this case also, no zeros. No zeros, right? You can also state it as no real root. No real root. So those are the examples that we have to know with regard to the graphs. Now let me give you another illustration. Say for example, there is a graph like this, which hits at 0, then goes up like this, and the points are given. This is 0, 0. This point is state 2, 0, and this point say negative 2, 0, and they're asking you to find all the zeros, right? So what would your answer be? Find all the zeros. This is a question they're asking you. Find all the zeros. So what would your answer be for this? This is x-axis, this is y-axis. I should have also placed x-axis, y-axis, x-axis, y-axis, x-axis, y-axis, x-axis, y-axis. So what are the zeros that you think this graph has? Now clearly there is an intersection here. You're right, there is an intersection here. There is an intersection here. There is an intersection here. So you can state that the graph has 3 zeros. The graph has 3 zeros, namely x is equal to negative 2, x is equal to 0, and x is equal to 2. On the other end, you can also say the function has 3 roots, namely negative 2, 0, and 2, right? Either like this or like this. So let me move on to another illustration. Say, suppose we have a graph like this. Okay, let me give you this graph x and y. The graph comes like this and hits 0 and moves up. There's only a hit at 0. and this is 1. Let me give you one more. This is x-axis, y-axis. The graph is coming like this. It hits here. After hitting 0, it comes out down and moves. This is a lovely graph, right? It hits 0 and it comes down and then it moves up. This types of graphs you will find more in economics, right? The best illustration for this, say for example, a company is getting started, right? Imagine a company is getting started. The company is climbing up slowly, or it can also be related to an individual. So let me start with the company. A company is growing, it is moving up and it hits 0. Remember, hitting 0 is not all the time bad. People always say, oh, a person has hit 0, so the person is doomed for failure. No, it is not so. Don't think getting or hitting 0 is a bad concept. No, it's not a bad concept. So it opens up a lot of introspective thought process. So this company is moving up the scale. Suddenly it hits 0 and then it goes down. It goes down and then it climbs up. Now this phase is a very important phase. This can be related even to an individual. The individual is getting negative marks and suddenly he or she starts to put in his work. So he gets up in the morning at 4 o'clock and works out, studies, reads. So from negative score, his score is moving up and hits 0. Right? After hitting 0, probably he gets discouraged and then he goes down again towards the negative axis, and suddenly he makes up his mind. He says, no, even though the outcomes are not really good, I will work and stay consistent. So that is the key, and then he again climbs. So this is a beautiful illustration of somebody who wants to achieve in life, right? All you need to do is to stay consistent. So this is the key word. You have to stay consistent. Consistent, C-O-N-S-I-S-T-E-N-T. This is the magic word. You can call it as a magic or whatever, secret or anything for that matter. All you need to do is in life to achieve wherever you want, you have to stay consistent. That's the important point. Apparently it says that majority, Anyway, that's I reserve it for some other point in the lesson to give you more insights. Now, having mentioned you all those things, you can clearly see in this case, they're asking you how many zeros. Okay, this is the question they might ask you. Find the zeros in this graph or find the roots in this function. Now, clearly, x is equal to 0 is the only 0 here, right? Now over here, x is equal to 0, and if this point is given to be, say, x is equal to 2, 0, then x is equal to 0 and x is equal to 2 are the zeros here. So as I mentioned to you, you can either use the term zeros or you can substitute zeros to be as roots. It doesn't matter. They mean the same. Now clearly you can see, if they say this is a cubic polynomial, say for example this is a cubic polynomial, the degree of this polynomial is 3. But the number of roots that we are getting is 2. Now remember, the degree is 3, the roots will not go beyond the degree. So that's a very important point you have to know. So I can clearly state that this is a very important note you have to know. So what is the note? If the given polynomial as a degree n, then it will have at most n zeros, maximum, that's all. It won't go beyond that. Say for example, if p of x has degree 3, then p of x will have at most 3 zeros. You can either use the word zeros or at most 3 roots. It will never go beyond this. You follow me? This is all important, right? All important property connecting roots with polynomials. So relationship between polynomial, what do you call this property? Relationship between polynomial and roots. You can either use the word roots or zeros, right? This is a relationship. So what is the relationship? If a polynomial given has got n roots, then the utmost number of zeros that this polynomial can have is n. It won't go beyond that. Example, if it has 3 roots, or in other words, the polynomial having 3 as its degree, then the number of possible roots, utmost possible roots, will be 3. That would mean it is not necessary that the polynomial should have 3 roots all the time. No, it can be 3, it can be 2, it can be 1, or it need not have to have any zeros at all. There are polynomials which have no zeros, no real zeros. So when I say zeros, they will not have any real zeros, right? So that is the key word, real. But anyway, I will not go into that topic as of now. I will introduce to you slowly as we gravitate more into the subject. Okay, so let us see the following illustrations. See, they have been given us the following illustrations. We've been given a graph, the following graph. The graph is like this. You are asked to find the number of zeros. Probably I'll just use one ink to avoid delay. These are the work given in your textbook, right? I'm not doing anything out of your syllabus. So whatever your syllabus is giving me, I'm doing the same thing for you all. So you don't have to worry. So okay. Find out the number of zeros. The question is find the number of zeros. So you have question 1, question 2, question 3, 4, 5 and 6. So can you tell me the number of zeros over here? This is a 0. Number of zeros. There is only one intersection. If somebody is asking you, why do you say the number of zeros is just 1 in question number 1? So you are giving here the number of zeros is equal to 1. They are asking you why. Simple. Your statement should be like this. Since the graph intersects the x-axis at just 1 point. You follow me? This is your explanation. This should be your explanation. Remember the sentence formation. If someone is asking you why is this the case, why? So you need to answer that why with the justification. Why? Because the graph intersects the x-axis at just 1 point. So justification is a very important part of mathematics. You will have to learn to write, right? So practice writing. Okay, coming back to the question. How many zeros question number 2 has got? The number of zeros is equal to what? 2. You have an intersection here. You got an intersection here. And someone is asking you why it has got two zeros, or how can you say? Always in mathematics they will ask you this question. How can you say? Immediately you should say, since, let me write that down. Since the graph intersects the x-axis at just, in fact you don't need to, if you want you place at just 2 points. You can alternatively write the graph intersects the x-axis at 2 points only. You can either use adjust, or if you don't want to use adjust, you can simply write it like this: since the graph intersects x-axis at 2 points only. Either like this or at just 2 points. And how many intersection does this have? I'm just going to state the intersection here, right? But you, if they're asking you to write it, justify, you will have to write this. You will have to write this as well as this. You got to be very much specific. And you cannot leave things for chances. You cannot say or assume, okay, the examiner will understand. No, don't allow that. Remember, when you're writing an examination, you have to assume that people want you to prove to them everything that is being asked. Of course, time is the constraint. If everybody is given all the time in the world, then everybody would get A, right? So you will have to practice that skill of writing fast. Okay, coming to question number 3. How many intersections does this have? 1, 2, and 3, isn't it? You see that 3 points of intersection. So this has got 3. And how many intersections does this particular graph has got? There's only 1 intersection. So this has got 1. And how many intersections this has got? This has just got 1. Why? You got to specify. Why? You see, there is only 1 point. The graph intersects the x-axis at just as 1 point. So y will also be there. So in this case, how many intersections? 1, 2, 3, 4. How many zeros this polynomial has got? You can say that 4 zeros. Question number 6, it has got 4 zeros, and you state the y. Right? The y is important, and you will have to follow this. The graph intersects the x-axis at 4 points only. Make sure to place, if you're writing the points, make sure to place at 4 points only. That is actually imperative, that is necessary. Okay, so now you have some list of questions. So let's see exercise 2.1. So over here we got exercise 2.1 from your textbook, right? So we got the following graphs. Question 1, x-axis, y-axis. This is the graph that we've got. And question 2, x-axis, y-axis. The graph is like this. X-axis, y-axis. The graph is like this. And let me squeeze the next question here. The graph is like this. And then the x-axis, y-axis. You got to specify this, x-axis, y-axis. Now for this one, it goes like this, it comes and then it rises up and goes down. And then finally, you have like this, it hits here, it goes up, it hits down, and then it goes up. Every hit is considered a point. So how many, does this have a 0? No zeros, no. Why? There's no intersection in x-axis. Does it have a 0? Yes. Zeros, how many zeros it has got? Zeros, it has got just 1. There's 1 intersection. Now you got to specify this. The graph intersects the x-axis at just 1 point. This line is imperative. Over here, how many intersections? You got an intersection here, you have an intersection here, you got an intersection here. Number of zeros? 3. How many intersections here? 1 and 2. 2 intersections. How many intersections here? Intersection here, there's an intersection here, there is an intersection here, there is an intersection here, there is an intersection here. 1, 2, 3, 4, 5. 5 zeros. It has got 5 zeros. So you can state it. The graph has got, the graph intersects the x-axis at 5 points only, right? So how many zeros this has got? There's an intersection here, 1, 2, 3, 3 zeros, right? So this completes our exercise 2.1 along with the complete introduction as well as all other terms. Students, in the next class we will study about relationship between zeros and coefficient of a polynomial, right? So hope to see you in the next class. Thank you, students.